Just a minute. Okay, good afternoon, everyone. In our previous lecture, we discusses about the basic information or a fundamental information about atom or how atom was formed, how where atom is present. Okay, and what is the size, what is the diameter of atom, what is the precise size of atom. After that, we also discussed about the nucleus, or inside the nucleus there are equal number of neutron and protons are present, and above the nucleus there are orbital shells are present, and inside the orbital shell there are number of electrons are present. Okay, so that point we already discusses. Okay, so without nucleus, without atom, without electron, the subject of nuclear physics is useless. Okay, so neutron, proton, electron, these are the radiation sources. Okay, and whenever we talk about the radiation, so of course we are familiar with the nuclear at that time. Getting my point? So I hope that you aware about the nucleus, neutron, proton, and electron. That is the building block of atom. Okay, inside the atom or bunch, in the bunch of neutron, proton, and electron, that is nothing but a atom. Okay, so I hope that that fundamental information you must be remember during the nuclear physics subject time or during the lesson of nuclear physics time. इथपर्यंत ठीक आहे ना? काही प्रॉब्लेम, काही डिफिकल्टीज? इथपर्यंत काही डिफिकल्टीज किंवा काही प्रॉब्लेम्स?
No, sir.
ओके, ठीक आहे. Okay, so uh, now I request to everyone, say present inside the chat box. Those who are present in our today's lecture, say present inside the chat box. So we know that the atomic nucleus means inside the atom there are a nucleus. Okay, so Rutherford established the atomic nucleus is the central core of every atom. Okay, so who is the discovered about the theory of atom or nucleus? That scientist name is Rutherford. Okay, so whenever we talk about the atom or nucleus, at that time suddenly the name was came in our mind, that Rutherford. Okay, so he suggested that in the entire positive charge, almost entire mass of the atom are concentrated. Okay, the atomic nucleus is regarded as a tiny sphere of diameter ranging from 10 raised to minus 15 meter to minus 14 meter. I already told that the atomic size, the size of the atom is 1 angstrom, that is 1 into 10 raised to minus 10 meter. Okay, or we can say 10 raised to minus 10 meter is the size of atom. After that, if we go inside the nucleus, okay, so nucleus having a size or having a diameter size is around 10 raised to minus 14 to 10 raised to minus 18, or 10 raised to minus 14 to 10 raised to minus 15 meter. Getting my point? After that, most of the places around the nucleus is an atom is empty space. Most of the place around the nucleus, I am talking about the around the nucleus. Most of the place around the nucleus is an atom is empty space. It means around the nucleus, what type of source are available? The question is open to all. Around the nucleus, which type of charge particles are available? कोणता चार्ज पार्टिकल प्रेझेंट असतो न्यूक्लियसच्या भोवती?
Electron.
कोणी सांगितलं हे?
Me.
Okay, absolutely right. The around the nucleus, that is the charge particle. Charge particle means what? Such type of particle, those who have a charge. Okay, for example, proton have a positive charge, neutron have a, काय असतो न्यूट्रॉनला चार्ज? इलेक्ट्रॉन have a negative charge, some of the ions radiation have some of the charge alpha particle.
Neutron.
What? काय असतो न्यूट्रॉनला चार्ज? Neutron does not have any charge. Neutron is electrically neutral. Neutron does not have a positive as well as negative charge. Okay, so that is the charge particles are occupied above the nucleus, that is the electron. And nucleus of atom consists of positively charged, that is the proton, and negatively charged, that is the neutron. Sorry, neutral particle, that is the neutron. Okay, so inside the nucleus, you must be remember that there are two particles, that is the proton and neutron. Okay, so neutron have a electrically neutral. It means does not have any charge, but proton have a positive charge. And above the nucleus, there are a electron, and that have a निगेटिव्ह चार्ज. इलेक्ट्रॉनला निगेटिव्ह चार्ज असतो, प्रोटॉनला पॉझिटिव्ह चार्ज असतो. ओके, सो okay, so let us start the exact topic of nuclear physics or exact points of nuclear physics. Okay, as we know in a periodic table, as we know the periodic table, as we know the atomic number, mass number. Okay, but that is the fundamental information of periodic table. Okay, आपल्याला periodic table माहिती आहे, atomic number माहिती आहे, पण what is meant by mass number, what is the role of mass number, what is the role of atomic number, how we can calculate a neutron, how much amount of neutrons are present, how much amount of electrons are present, how much amount of protons are present, or how we say that is the isotope, that is the isobar, that is the isomer. Okay, isochore, how we can say that is. Okay, so that we calculate by using this term. So what is mean by atomic number? Atomic number म्हणजे काय असतो? It means the number of protons present inside the nucleus of an atom, that is called atomic number. Okay, it means inside the atom, how much number of atoms are present? Sorry, how much number of protons are present? Okay, suppose uh, suppose this is the atom. Okay, and there are equal number of proton and equal number of electrons are present. Suppose this is the electron, sorry, equal number of neutron and equal number of proton present. So a dark portion indicates a neutron, and empty space or whole type of area indicates a proton. Okay, this is another proton, this is the another neutron. Okay, and suppose this is the helium atom. Okay, this is the helium atom. So we can say that here the helium have a two atomic number. It means inside the helium atom there are two protons present inside the nucleus. Getting my point? So that is nothing but a atomic number. Atomic number we can calculate the in, uh, calculate the presence of proton. How much number of protons are present? Okay, that is the atomic number, and it is equal to the number of electrons present in that atom. Okay, it is equal to that number of electrons present in that particular atom. त्या atom मध्ये किती इलेक्ट्रॉन प्रेझेंट आहेत त्याच्याने आपण सांगू शकतो. अँड ॲटॉमिक नंबर, ऑफकोर्स ॲटॉमिक नंबर इज रिप्रेझेंटेड बाय ए कॅपिटल झेड. ओके, तर ॲटॉमिक नंबर हा न्यूक्लिअर फिजिक्समध्ये कॅपिटल झेडने रिप्रेझेंट करतात. ओके, so that it may be possible to ask the MCQs based question that the atomic numbers are represented by dash dash dash. So A, capital A, B, capital Z, C, capital N, and D, capital M. Okay, so you must be aware that atomic number represented by capital Z. Okay, so what is mean by mass number? What is mean by mass number? Of course that lesson you already learn. हे सगळं झालेलं आहे तुम्हाला. कधी झालेलं आहे? TYBSC ला झालेलं आहे. पण इन शॉर्ट आपण हे घेणार आहोत बिकॉज दॅट इज नेसेसरी, दॅट इज इम्पॉर्टंट टू स्टार्ट दी point of binding energy, mass defect, or packing fraction. Okay, so that is we will discuss in short of this topic. So what is mean by mass number? Okay, so next point is mass number. Mass number of an element is that total number of protons and neutrons present inside the nucleus of that particular element. So suppose this is the helium atom. Suppose here this is the helium atom. Okay, and inside the nucleus there are two protons. Suppose this is the proton. मी जे काही स्केच काढतोय ते दिसतंय का तुम्हाला? Can you see this sketch? Whatever sketch I have drawn here, दिसतंय का तुम्हाला? Okay.
Yes, sir.
Okay, so look at here. Here is the proton. Okay, empty space or empty whole space indicates a proton, and a dark shaded region that indicates a neutron. It means that mass number is nothing but a equal number of proton and equal number of neutron. Okay, and if we calculate or if we add that proton and neutron, if we make an addition of that proton and neutron, that is nothing but a mass number. Okay, that is nothing but a mass number. Okay, so whatever number of protons and neutrons are present inside the nucleus, that is a mass number, and which is denoted by capital A, which is denoted by capital A. It means that helium has a atomic number 2 and mass number is 4. Okay, how mass number is 4? Because here two protons and two neutrons are available. Okay, so I hope that you must be understand that point. Now number of protons means the number of electrons too. Means equal number of protons and equal number of electrons are present inside the atom. Okay, so number of nucleons is nothing but a number of nucleons is represented by also capital A. Mass number and nucleons, that is nothing but the same. Nucleus and nucleons are different. Huh? Keep in your mind that nucleus and nucleons are different. Okay, so nucleons means nothing but a number of mass number. So nucleons is nothing but nucleons is also denoted by capital A. Nucleons are also denoted by capital A. So how we can calculate a number of neutron? Okay, how we can calculate a number of neutrons? So nucleon number of neutrons are calculated that number of neutrons is equal to nucleons minus atomic number. Okay, or we can say that mass number minus atomic number. Okay, so here the it is possible that neutrons may be vary. Okay, neutrons may be vary. It may be a gain, it may be a lose. Okay, according to the atomic number or mass number. Okay, if suppose that if we calculate a number of neutrons, so if suppose that atomic number or mass number is 5, suppose A is equal to 5 minus Z is the 2, that is the helium atom. Okay, so in that case we got a answer 3. It means here is the atomic number is 2. Okay, sorry, Z is the atomic number and 5 is the what? 5 is the mass number or nucleons. So we got a number of neutron is 3 number. Okay, in this way we can calculate. Now mass number is represented by in this way. The mass number is represented by in this way, that is this in this way. Okay, A is the atomic number, A is the nucleons or mass number, or Z is the atomic number, but entire mass number which is represented by in this way. So Z is the atomic number, A is the mass number, and X is the chemical symbol of element. Okay, chemical symbol of element means particular element. X काय हा particular element आहे. For example, here we have taken sodium atom. Sodium atom आहे हा आपल्याकडे. त्याचा atomic number काय आहे? 11. 11 is the atomic number and mass number is the 23. Okay, and if we plan to calculate a what number of neutrons, so we can calculate here. Therefore, if we calculate a number of neutrons, so here A is what? A is the this point. A is this point. That is 23 minus what? 11. Okay, 11 is what? Z, that is atomic number. Okay, so let us say 11, which is equals to how much? That is 13. Okay, that is 13. Am I right? So it means that number of neutrons are present inside the sodium atom is 13. Okay, 13 is the number of neutrons. But here we say that number of protons and number of neutrons are equal. Okay, or we say that the number of protons in the mass number is what? Total number of protons and neutrons are present inside the element. आता आपण मास नंबर काय म्हणतोय की नंबर ऑफ प्रोटॉन आणि नंबर ऑफ न्यूट्रॉन सारखे असले पाहिजे. ओके, त्याला मास नंबर म्हणतो आपण. बरोबर बरोबर का? नंबर ऑफ प्रोटॉन आणि नंबर ऑफ न्यूट्रॉन सारखे असले पाहिजे, त्याला मास नंबर म्हणतो आपण. बरोबर का? बरोबर का? अभिषेक, अंकिता, बानू, एकनाथ, हजारे. Oh, sorry. Shin, absolutely right. That is the 23 minus 11 is the 12. That is the 12. That is the 12. 23 minus 11 is the 12. Okay. So that if suppose neutron is 12 and here the mass number indicates a 23. Okay. Here the mass number is indicate 23. If suppose neutron is 12 and we say that according to the definition of mass number, equal number of proton and neutron present inside the nucleus, that is the mass number. Equal number of sorry, not a equal number of sorry, not a equal number of, it means how much number of protons and how much number of neutrons present, that is the mass number. Okay, so here the mass number is 23. Okay, and here is the neutron is 12, it means that protons are 11. ओके, त्याच्यामध्ये प्रोटॉन किती असतील 11. आणि if we make a addition of neutron and proton, if we make a addition, आपण न्यूट्रॉन आणि प्रोटॉनचं ऍडिशन केलं तर न्यूट्रॉन किती आहेत आपल्याकडे 12. we have a 12 neutron plus proton किती आहेत 11. okay, so we got a mass number that is 23. okay, so that is nothing but a mass number. I hope that की तुम्हाला हे समजलं असेल. You have to take a screenshot. Okay, screenshot घेत चला. समजलं का हे slide? Did you understand this slide? Did you understand this slide? काही शंका? हे ऑलरेडी झालेलं आहे तुमचं TY ला. Okay, so let us go next point. That is the isotope. What is mean by isotope? What is mean by isotope? Okay, suppose एखादा एलिमेंट असेल, एलिमेंटच्या बारच्या सेशनला काहीतरी नंबर लिहिलेला असेल आणि डाऊन साइडला काहीतरी नंबर लिहिलेला असेल. त्याच्या वेळेने आपण आयसोटोप काय असतो, आयसोटोप कोणाला म्हणू शकतो वगैरे ते कसं कॅल्क्युलेट करायचं ते आपण बघणार आहोत. ओके, so isotope is the same number of protons but different mass number. Okay, isotope is the same proton but different mass number. Okay, if we consider a single element or single material, suppose here we have taken the example of carbon element or carbon material. Okay, so here nuclei with the same atomic number. Okay, आपल्याला माहिती आहे कार्बनचा atomic number किती आहे 6. nuclei with a same atomic number. Okay, या ठिकाणी पण बघा, let us see, look in this picture and also look in this picture. Okay, both have a same mass number but different mass number, same atomic number but different mass number. Okay, now look in above upward side of carbon atom, this one. Here is the mass number is 12, here is the mass number is 13. Okay, so that is nothing but a isotope. Okay, that is nothing but a isotope. Isotope means what? in a single element, in a single atom, there are the same number of protons but different mass number. Okay, same number of protons, atomic number or protons are similar. Okay, near about same. And how we can uh, identify, how we can distinguish about the isotope? We can distinguish that isotope is nothing but a same number of protons. Look at here. We have also taken one more example about uranium material. Uranium have a 92 atomic number. Look at here. Uranium have a 92 atomic number, but the mass number is different. That is 238 mass number and 235 mass number. Okay, so that's why uranium have a unstable material. Okay, because uranium does not have a same mass number. Okay, that is the different mass number. And if we calculate that mass number into atomic number, so we got a different neutrons. Okay, it means that such kind of materials are unstable. आणि जे मटेरियल हे अनस्टेबल असतात त्या मटेरियल मधनं रेडिएक्टिव्हिटी किंवा रेडिएशनल सोर्स इमिट आउट होतो. ओके, फॉर एक्झाम्पल carbon also a unstable material we can see here. Okay, so that is nothing but a isotope. Isotope indicates a same number of protons. Okay, or otherwise same atomic number but different mass number, that is called a isotope. Okay, so it may be asked for MCQs based question like that. The question may be arises that may be asked that the nuclei with same atomic number but different mass number is dash dash dash. There may be an option like isobar, isotope, okay, or isotones, isomeric. Okay, these are the options. Now about a isobar, look it into a isobar. What is mean by isobar? Okay, so in case of isobar, there are a same mass number but different protons number. Okay, here is the same mass number. In case of isobar, here is the, in case of isotope you must be focused on topper side. Okay, isotopes तुम्हाला आरामात किंवा इझी वेने लक्षात ठेवण्यासाठी तुम्ही कसं लक्षात ठेवायचं, तर आयसोटॉप मध्ये टॉप लेवलची बाजू जी आहे ती डिफरंट वेने तुम्हाला दिसेल. ओके, यू कॅन आयडेंटिफाय इन दिस वे आयसोटॉप्स. तर टॉपची जी बाजू आहे दॅट इज द डिफरंट, इट मीन्स द डिफरंट मास नंबर. इन केस ऑफ आयसोबार, ओके, तर आयसोबार मीन्स टॉपची बार मीन्स निगेटिव्ह साइड. ओके, टॉपची निगेटिव्ह साइड, दॅट इज द आयसोबार. लेट अस फॉर बेटर अंडरस्टँडिंग पर्पजेस आपण या वेळेने लक्षात ठेवू शकतो की आयसोबार मीन्स टॉपची निगेटिव्ह साइड. बार आपण लिहितो म्हणजे काय, अपोजिट डायरेक्शन असते. ओके, so in this case, in case of isobar, in a nuclei with same mass number but different protons or but different atomic number. Okay, that is nothing but a isobar. आता याच्यामध्ये we have taken the example of a helium atom. Okay, helium, and here is also helium, and here is the mass number is 3, and here is also the mass number is 3. That is the same mass number. We can see easily here. Here is the same mass number, but in case of atomic number, both have a different atomic number. Okay, but if we calculate a neutron, that is also different we observed here. Now look it into the third type, that is isotones. What is mean by isotones? Okay, what is mean by isotones? Okay, so isotones mean what? Same neutron but different atomic number. Isotones is nothing but a same neutron but different atomic number. In this case, both are like mass number and atomic number both are different, in but the neutrons are same. Okay, look at here. In case of isotones, mass number and atomic number, or mass number and protons number both are different, but the neutrons are same. Let us say how, because here in this case, okay, in this case, let us calculate a carbon. So 14 minus 6 is nothing but a how much? 8. 14 minus 6 is the 8. 8 is the neutron. And 16 minus 8, that is also 8. 8 is the neutron. So it means that isotone indicates a same neutron. Okay, isotone indicates a same neutron but different atomic number or different protons. ओके, तर तुम्ही इथं बघू शकतात की न्यूट्रॉन सारखे आहेत. ओके, न्यूट्रॉन सारखे आहेत दोघीही केसमध्ये. नाव आयसोमेरिक. ओके, आयसोमेरिक म्हणजे काय? ओके, व्हॉट इज मीन बाय आयसोमेरिक? सो इन दिस केस सेम mass number, same Z. Okay, same mass number and same Z means what? Same number of atom, same atomic number, but different internal structure. ओके, या केसमध्ये काय होईल की मास नंबर पण सारखा आहे, ॲटॉमिक नंबरही सारखा आहे किंवा प्रोटॉन्स पण सारखे आहेत त्याचे. ओके, बट डिफरंट इंटरनल स्ट्रक्चर. ओके, दॅट डिफरंट इंटरनल स्ट्रक्चर, that is nothing but a isomeric. Okay, so these are the 4 important parameters about the radioactive materials or about the nuclear materials. Now fifth type is mirror nuclei. What is mean by mirror nuclei? Okay, so according to the name, mirror means we can observe a same image in opposite direction, that is the mirror. Okay, and mirror nuclei means nuclei with same mass number A but with proton and neutron number interchanged. Okay, look at here, nuclei with same mass number, this is the important point, same mass number, but protons and neutrons number interchange and their difference is plus or minus 1. That is the parity number, that is the plus 1 minus plus or minus 1. Okay, neutron mirror nuclei मध्ये मास नंबर हे सारखेच असतात, पण प्रोटॉन आणि न्यूट्रॉन हे एकमेकांशी इंटरचेंज करतात. इट मीन्स एखाद्या एलिमेंट मध्ये जर प्रोटॉन जास्त असतील तर दुसऱ्या एलिमेंट मध्ये न्यूट्रॉन कमी असतील, आणि दुसऱ्या केसमध्ये दुसऱ्या मटेरियलमध्ये प्रोटॉन कमी असतील आणि एखाद्यामध्ये न्यूट्रॉन जास्त असतील. असं इंटरचेंज डिफरन्स किती असेल तर प्लस और मायनस 1 चा असेल. ओके, नाउ लुक इट हियर, we have took one example for that case, like a carbon element. Okay, carbon element if we choose, so carbon here 6 is the atomic number. Okay, and 11 is the mass number, and now we are calculating neutrons. Okay, so 6 is the proton also and 6 is the atomic number also. Now if we calculate a what neutron, so 11 minus 6 is equal to 11 minus 6 is equal to how much? 5. Okay, and in this case if we calculate about this equation, so here the 11 minus 5 is equals to 6. Okay, तर या केसमध्ये डिफरन्स कितीचा आहे? we can easily obtain that here is the neutron is 6 and here is the neutron is 5. Okay, and that is the interchange, proton or neutron is interchange. Here is the proton, look at here, this is the proton, proton is 6 here and proton is 5 here. Okay, आणि हा प्रोटॉन इकडे 5 आहे आणि इकडे 6 आहे. Okay, and in this case here proton is more and here is in this case the proton is more and in this case neutron is less. Okay, but in the opposite direction here is the neutron is more and here is the proton is less. Okay, it means that mirror nuclei have a same number of A but with proton and neutron number interchanged. Okay, and their difference is plus or minus 1. Okay, आणि याच्यामध्ये तुम्हाला डिफरन्स दिसत असेल, इझिली वी कॅन आयडेंटिफाय द डिफरन्स. ओके, सो हियर इज द प्रोटॉन इज मोर and neutron is less, but in the opposite case neutron is more and proton is less. समजलं का मिरर न्यूक्लिआय? समजलं? समजलं का मिरर न्यूक्लिआय काय असतो? yes or no? शिंदे, अंकिता, Shweta. Okay, so this is the basic information. Now let us move towards the next slide. What is meant by nuclear size? Okay, what is meant by nuclear size and how we can determine the size of the nucleus? Okay, so that it is experimentally found that volume of nucleus is proportional to its mass number A. Okay, it means particular volume of the nucleus is proportional to its mass A. That is the nothing but a nuclear size, and we can calculate a nuclear size in terms of radius of the particular nucleus. Okay, and by using this equation, 4 by 3 pi r cube is directly proportional to A. Okay, directly proportional to A means volume of the nucleus. Okay, volume of the nucleus means 4 by 3 pi, and r is the radius cube. Okay, to its mass number, proportional to its mass number, and A is the mass number. Okay, so where r is the radius of nucleus, and according to that r is directly proportional to A raised to 1 by 3. Okay, where uh, if we solve that term, if we calculate this term, so we got r is equal to r0 a raised to 1 by 3. Okay, r is equal to r0 a raised to 1 by 3, where here r0 is the empirical constant. This term, that r0 is the fundamental or empirical constant, and a is nothing but a what? A is the mass number. Okay, and if we know the mass number, and if we know the empirical constant value, that is 1.2 femtometer here, that value is given here. 1.2 femtometer means what? 1.2 into 10 raised to minus 15 meter. Okay, that value we already know, that is the fundamental constant, that is the empirical constant. And if we know this value, ही value जर आपल्याला माहिती असेल, so by using that value we can easily calculate a radius of the nucleus, or nuclear size, or nuclear size. Okay, but when we can identify the nuclear size, in that case we need a particular material's mass number. Okay, आपल्याला a माहिती पाहिजे. Look it here in this formula. You can use r is equal to r0 a raised to 1 by 3. Suppose a आपल्याला माहिती आहे, आणि a जर माहिती असेल तर आपण a च्या ठिकाणी त्या व्हॅल्यू पुट केली, आणि त्या पर्टिक्युलर मास नंबरला ए वन मास नंबरला त्याचा रेशो ए रेस टू 1 बाय 3 ने मल्टिप्लाय केला, किंवा त्याला ही टर्म सॉल्व्ह केली, तर आपल्याला ए रेस टू 1 बाय 3 सॉल्व्ह केल्यानंतर या व्हॅल्यू मध्ये पुट केलं की आपल्याला रेडियस, पर्टिक्युलर न्यूक्लियसचा रेडियस मिळून जाईल. गेटिंग माय पॉइंट? नाउ द न्यूक्लियर डेन्सिटी. व्हॉट इज मीन बाय न्यूक्लियर डेन्सिटी? Okay, so nuclear density is the ratio of mass of nucleons to its volume. Nuclear density or nucleus density, huh? So density, we already aware that what is mean by density. Okay, but here we will focus on nuclear density. So nuclear density is what? Nuclear density is the ratio of mass of nucleus to its volume. Okay, that is nothing but a nuclear density. Now let us consider one example. If m is the average mass of nucleon, okay, here m is the average mass of nucleons, then mass of nucleus is m into a. Okay, where this m is nothing but a average mass of nucleon, and a is the mass of a particular atom, or mass number of particular atom. So that how we can calculate the volume of nucleus, particular volume of nucleus? So volume of nucleus is equal to 4 by 3 pi r cube. Okay, हे बघा इथं पण आपण व्हॉल्यूम ऑफ न्यूक्लियस घेतलेला आहे. Okay, so volume of nucleus is equal to 4 by 3 pi r cube, which is equal to 4 by 3 pi r cube is nothing but a, we know that r cube ची व्हॅल्यू आपण कॅल्क्युलेट केली न्यूक्लियर साइज मध्ये, हियर या ठिकाणी केली आपण बघा. Okay, that is the value of r. Okay, and if we put the value of r so that r0 a raised to 1 by 3 and that bracket cube, that is nothing but a volume of nucleus. And if we solve this term, if we solve these terms, we got the final expression, that is 4 by 3 pi r0 cube a. Okay, where that 3 get cancelled. Okay, for the particular atomic mass number. Okay, so now the nuclear density, which is represented by rho, nuclear density, whenever we calculate, whenever we solve the density, that density is denoted by rho. Okay, nuclear density is nothing but a ma, that is the mass of nucleon, then mass of nucleus is ma, that ma upon 4 by 3 pi r0 cube a, that is the nuclear density. If we solve that term, so here a get cancelled. Okay, so and that denominator side 3 shift towards the numerator side, so we got 3m upon 4 pi r 0 cube. Okay, so that is the final expression of nuclear density. Okay, so you must to remember that this formula. Okay, also this formula. Okay, so in this slide you must to you must be remember that the formula of nuclear size and nuclear density, because according to the MCQ based question paper, you have to aware that they may be asked the the nuclear size or the diameter of nucleus is represented by dash dash dash, that is option r0 a raised to 1 by 3, r0 a raised to 2 by 3, r0 a raised to 5 by 3, or r0 3 by 2, a raised to 3 by 2. In this way they may be asked. Okay, and about the nuclear density, they may change this equation in various type. Okay, so you have to choose the correct one. This equation represent a rho is equal to 3m upon 4 pi r0 cube. Okay, and it is the order of 10 raised to 17 kilogram per meter cube. Nuclear density that may be come in the order of 10 raised to 7 in kilogram per meter cube. Okay, it means we obtain the nuclear density value, that is dash 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 into 10 raised to 17 kilogram per meter cube. Okay, we can obtain in this way. Okay, so here the dash value are the calculated value of particular nucleus, and after that we got a order, that is 10 raised to 7 kilogram per meter cube. Okay, so here we have a less than 1 minute time, so I request everyone rejoin again. एका मिनिट पेक्षा कमी टाइम शिल्लक आहे, प्रत्येकाने परत जॉईन करायचे आहे. चालेल ना, काही प्रॉब्लेम? जॉईन करू शकतात ना? अटेंडन्स लावा बरं पटकन, ज्यांचं राहिलं असेल त्यांनी.